How's everybody doing today? Decided not to go to the turkey bowl. Well, today we're going to learn about solving quadratic equations. There's four methods that we use: factoring, the square root method, completing the square, and then using the quadratic formula. There's some stipulations on some of these. Factoring we can only use if the equation is factorable. Square root method has to be set up in a certain way to use it. Completing the square is probably the most difficult of the four. So I would only go after that one if the directions specifically say to do so. And the quadratic formula has to be set up in a certain way, but it works for everything. So let's start on the second page where it says solve by factoring. We have 2x squared minus 9x minus 5 equal to 0. So the directions say solve by factoring, so we have to solve by factoring. How would I factor that? What would I do? Any ideas? There's many different ways to factor. Most instructors will teach this AC method, or splitting the middle term. 2 times negative 5 is what? Negative 10. I do ask questions, so be prepared. 2 times negative 5 is negative 10. Are there two numbers that multiply to give us negative 10 and also add together to give us negative 9? So what are the only two possibilities of multiplying to give us 10? 2 and 5 and 1 and 10? Any one of those will work for a negative 10 and a negative 9?
Positive 10, negative 1.
Close.
Negative 10 possible.
Yeah, it'd be a negative 10 and a positive 1. In order to add up to that negative 9. So what we're going to do is we're going to split our middle term into those two pieces we said would work. A negative 10 and a positive 1. Then I can do factoring by grouping. What can I factor out of that first pairing at 2x squared minus 10x? What's the greatest common factor there?
You can factor 2x.
2x. And that leaves me with x minus 5. What can I pull out of that second pairing? I have to pull something out. If I pull just a positive 1 out, that's not going to change my factor. Notice these two factors are the same. So x minus 5 and 2x plus 1 is my other factor. I would then set those factors equal to 0. So what would this answer be? X equals what? 5. The other one, we've got a little bit more work. 2x equals negative 1. So x ends up being negative. Okay. So those would be my two solutions. Once again, the directions said specifically we had to solve it by factoring, so we had to do it by that process. Any questions on that one? Let's jump to the next one. The next one says we need to solve this by the square root method. In order to do the square root method, you have to get the term that's being squared isolated. So how can I get x squared isolated? What would I need to do? Good. Let's add 24 to both sides. So x squared equals 24. From there, what I would do is take the square root of both sides. So So x, the square root of x squared is just x. We have to remember that I could get two possibilities, a positive or a negative answer. And the square root of 24 can be simplified. What can I break up the square root of 24 into to make it a simpler radical?
4 and 6.
4 and 6. 4 is the highest perfect square that goes into 24. And what is the square root of 4?
2.
2. So that comes out in front. And I do get two answers. A positive 2 square roots of 6 and a negative 2 square roots of 6. So for the square root method, we have to isolate our squared term. And sometimes it's a bigger term that's squared. But as long as we get it isolated, we can use the square root method. Any questions on that one? The next one we have to solve by completing the square. Completing the square is usually the one, the least favorable. It's usually the one that involves the most work. It has to be set up in a certain way. All your x's have to be on one side. And we're going to leave a little space here. I'm going to move this positive 1 over to the other side. We're also going to add a space there. Our goal is to turn this left side involving the x's into a perfect square trinomial, the completing the square part. What you want to do is take your b, your middle term, the part that's in front of x, take that and divide it by 2 and square it. That's going to be the number that's going to go into the blank on both sides. So 4 divided by 2 is what? 2, okay. And then 2 squared is 4. That's going to be the number that goes on both sides. So this x squared plus 4x plus 4 turns into a perfect square trinomial. Any factors of 4 that add up to 4? 2 and 2. And as a hint, whatever this number is divided by 2 is always going to be the number that goes here. And then on the other side, negative 1 plus 4 is 3. From here, we can use the square root property. We can take the square root of this side and that side. When I take the square root of something squared, what do I have left? Just what's underneath. Don't forget plus or minus. Does the square root of 3 break down into anything? Is there any perfect squares? No. So we'll leave it as it is. The only thing I could do now to get x by itself is to subtract 2. And just put that number in front. Negative 2 plus or minus the square root of 3. We can't combine them. One's a square root. One's a whole number. Or one's a radical, one's a whole number, so we just have to leave it like that. We do get two answers, negative 2 plus the square root of 3, and negative 2 minus the square root of 3. But notice completing the square is a lot more work involved. It has to be in a certain form. You have to manipulate one of the coefficients. You have to do factoring. You have to do the square root method. So there's a lot of work on that one. So like I said, I would only tackle that one in that method if the directions tell you to do so. Any questions? All right. The last one on this page asks us to solve it by the quadratic formula. So in order to use the quadratic formula, it has to be in standard form, which means it needs to be equal to 0. So what do we need to move over first? 3. Right. So x squared plus 8x minus 3 moved over becomes plus 3. So the quadratic formula, can anybody tell me what it is right off the top of their head? I know everybody's got it memorized.
Negative b plus or minus square root of b squared minus 4ac over 2.
Thank you, sir. I didn't even have to make anybody sing. That's good. So what would a be? A is the number in front of our squared term. 1. B would be 8, the number in front of x. And c would be correct. So we're just going to plug those values into our formula. So we'll move back over here. X equals negative b. Negative b just means the opposite of b. So negative 8 plus or minus b squared, so 8 squared, minus 4 times a, which is 1, times c, which is 3. And then that whole thing is over 2a. So 2 times a, 2 times 1. So let's simplify it. Negative 8 plus or minus. What's 8 squared? 64. Minus 4 times 1 times 3 is 12. And then 2 times 1 is 2. We have to simplify the radical first. Negative 8. What's 64 minus 12? 52. Any perfect squares that go into 52? I want to think of 1. So x equals 4 times 13. Once again, what's the square root of 4? 2. So I simplified the radical. Can I simplify the fraction any further? I've got this negative 8 plus or minus 2 square root of 13 over 2. Any ideas? I'm dividing by 2, so I can just divide both of these by 2. So what's negative 8 divided by 2? 4. Negative 4. And this 2 divided by 2 just becomes 1 square root of 13. So my answer becomes negative 4 plus or minus square root of 13. Okay. So those are the 4 methods and the steps that you need to take to do each one of those. What we're going to do now is we're just going to come across a whole bunch of problems, just say solve, and we're going to try to decide what the best method to use will be. Okay, so that'll be the back of the second page. Any questions with this one? Can I go erase it? Move on? Okay. So we have 4x minus 1 squared equal to 5. Which one of the methods do you think would be best here? Factoring, square root method, completing the square, quadratic formula?
Square root.
Square root. The reason being is you have something squared that has the variable on it equal to a number. It's already set up for the square root method. So let's do that. Let's take the square root of both sides. So the radical and the exponent cancel out here. And then plus or minus square root of 5. Can I break apart the square root of 5? Any perfect squares in that one? No. So how would I go about isolating x, solving for x here? Add 1. So if I add 1 over here, that's going to be 1 plus or minus the square root of 5. Last step. Divide by 4. And I look at my fraction to see if I can reduce it, but there's nothing common between 1, this one here, and this 4, except 1. So that would be my answer. I just leave it in that form. Now, could I have FOILed this out, rearranged it, and done some other form? Yes, I could have, but it's a lot more work. And we're trying to see, what the best method is. And for that one, it was the square root method, because it was already set up for it. Are there any questions on that one? Any ideas of where to begin on this one?
I would put all the x's in the
Yeah. We have a square term, but it's not really isolated. So the square root method kind of goes away here. So let's see what happens when we bring everything to one side. And set it equal to 0, putting it in standard form. So the first thing I want to say, well, can it be factored? Are there any factors of a positive 7 that will add up to a positive 12? The only two numbers that multiply to give me 7 are 1 and 7, right? Do those add up to 12? No. So if it doesn't factor, what does that lead me to? Yeah, it leads me to the quadratic formula. So what's A, B, and C? And we'll just plug it in. Right here. X equals B. So X is going to be equal to negative 12, the opposite of B, plus or minus B squared, 12 squared, minus 4 times A times C, all over 2A. So let's start simplifying. Negative 12 plus or minus. 12 squared is 144. 4 times 1 times 7, 28. That's all over 2. 144 minus 28 is 116. 2. Any perfect squares that go into 116? All I can think of is 4. 4 times 29. Once again, what's the square root of 4? Yep, so that's going to come out. And 29 can't do much with. So I have a fraction. I've already simplified my radical. Can I simplify that fraction any further? Yeah, I can divide that 2 in there because 2 goes into both of those. So what would my final answer be here? What's negative 12 divided by 2? Negative 6.
Plus or minus square root of 29.
Yeah, plus or minus square root of 29. That 2 divides into that 2 evenly, leaving with 1 square root of 29. So my final answer there would be negative 6 plus or minus the square root of 29. So we saw that we couldn't use the square root method. It wasn't really set up for it. We rearranged it in the standard form. We saw that it couldn't be factored, so we went to the quadratic formula. And that's really the pattern we should be following. Right. Let's try some more. Any questions on that one? Any ideas on this one? What method we might be able to tackle this one?
Right.
Yeah, I would say square method as well. It's not quite set up for it yet, but we do have a square term that's by itself. There's no x's anywhere else. So how could I isolate that? Subtract. Yep, so let's subtract 48 over to this side, and then divide both sides by 3. What's negative 48 divided by 3? Negative 16. So then I can take the square root of both sides. And I do have a term isolated that's squared. That's going to be x equals plus or minus, yeah. The square root of 16 is 4, but it's negative. So we have to remember that we can't have imaginary number solutions. So my solutions here would be x equals plus or minus 4i. Pretty straightforward. Any questions on that one? Good to go? Alright. Is it really set up with the square root method? Do we have an x term that's squared that we can isolate? No. We have x's in 2 different locations. So let's see if we can factor it. Now notice I can take a greatest common factor out of there. What would that greatest common factor be? 3? Yeah, and my suggestion is because it does lead with a negative to factor out the negative. So that's going to leave me with x squared plus 2x plus 2. We have to look at what we have remaining. The negative 3 does not have an x value with it, so it's not going to have anything to do with our solution. We're just focusing now on what we have left. Can I factor that? Are there any factors of 2 that add up to 2? No. The only thing that gives us 2 is 1 and 2, which would add to 3. It's not going to give us 2. So that tells us we have to go to the quadratic formula. So what would A be? 1. B? 2. C? 2. Equals 2 as well. So we're going right back to this equation again. X equals negative 2 plus or minus 2 squared minus 4 times 1 times 2 over 2 times 1. X equals negative 2 plus or minus. That 2 squared is 4. Minus 4 times 1 times 2, so minus 8. And what is 4 minus 8? Underneath that radical. Negative 2 plus or minus square root of negative 4. And what's the square root of negative 4? 2i. The square root of 4, negative 4, or the square root of 4 is 2, and because it's negative, can I simplify that fraction any further? Are both of those divisible by 2? Yeah, so it'll be negative 1 plus or minus I. Just take both pieces and divide by 2.
mentioned that the positive 4, why change to negative 4?
Well, 4 minus 8.
Okay, yeah.
Okay.
All right, yeah.
Anything else? We're good to go on that one? Right. So let's move to the top of the third page. X squared plus 12x plus 35. We don't have an x squared term that we can isolate because we have x squared and x. Is it factorable? Are there any factors of 35 that add up to 12?
75.
75. Good. And this is just 1x squared, so we don't have to do that splitting the middle term that we did earlier. We can just say, well, that's going to be x plus 7 and x plus 5. Then just set those factors equal to 0. So x equals negative 7, and x equals negative 5. Could I have plugged this into the quadratic formula if I wanted to? Yes, it just would have been a lot more work. So sometimes it's best to, once you're going to have that order, you can't use the square root property. Is it factorable? If it's not factorable, use the quadratic formula. This one was factorable, pretty straightforward. We get our answers that way. Any questions on that one? It's pretty straightforward with the factoring. Questions? Ready for the next one? I think I should attack that one. Yeah, square root property. I do have a square term that I can isolate. It's right here. So how would I isolate it?
Subtract 61.
Yep. We're going to subtract the 64 first, so negative 64 divided by 9. It's negative 64 over 9. Then I can do my square root, take the square root of both sides. So x ends up being equal to. Now with a fraction, you can split it up. You can split it up. Take the square root of the top and bottom separately. So the square root of negative 64 would be what? 8i. The square root of 64 is 8. Since it's negative, it has to be an imaginary, so 8i. And what's the square root of 9 on the bottom? 3. That'll be my answer. I still have those two answers, right? Plus or minus, plus 8/3 I and minus 8/3 I. We were just able to find them using the square root. Questions on that one? What is this one really set up for? Yeah, square root method again. We don't have x squared, but we do have a term, an expression squared equal to a number. So we can use the square root method there. What happens when I take the square root of something squared? It cancels. And plus or minus. Can I break apart the square root of 6? Any perfect squares that go into 6? keep like that. Now I just want to get x by itself. I want to solve for x. So what would my first step be?
Subtract 8.
We'll subtract that x. Subtracting that x is negative 8 plus or minus the square root of 6. And my last step would be to do what? Let's divide by 3. So x ends up being equal to negative 8 plus or minus the square root of 6 all over 3. We need to see if our fraction can be reduced any. Anything common between negative 8, 1, and 3? Those numbers? Yeah. There's nothing we can reduce or cancel here. So that would be nice. Any questions on that? Because the next one's a little bit more fun. Ish. Alright. Sometimes things that don't even look quadratic in the beginning may lead us to a quadratic equation. So I have a rational equation here, an equation involving fractions with variables. So how could I solve this equation? What would my first step be? How can I clear a fraction with equation, or clear a equation with fractions? Yeah, I could multiply by my LCD. So what would my least common denominator be here? I have 5 and an x and an x minus 3. So what I could do is say that my least common denominator is 5x times x minus 3. And we're going to use that to clear our fractions out. What would I need to multiply my first fraction by in order to get it the same LCD? It has an x, so what is it missing compared to my LCD? 5. And what else? X minus 3. What's the middle fraction? What is it missing compared to my LCD? 5x. And this last fraction, what is it missing?
X times X minus 3.
Correct. It's missing x. And x minus 3. So let's rewrite our fractions. They're all going to have the same denominator now. Our LCD, 5x, x minus 3. And we're going to actually multiply our numerators out. So we have 6 times 5x minus 3. Couldn't I just say 6 times 5 is 30? So that's 30. And then take 30 times x minus 3. So what's 30 times x minus 3?
30x minus 90.
X minus 90, correct. X times 5x, that's a little bit easier. 5x squared. And then I have 4 times x minus 3. I could say this is 4x times x minus 3. So what would that give me?
4x squared minus 12.
Correct. 4x squared my equations or all my fractions with the same denominator, I can just multiply by my LCD. And what's going to happen to all those denominators? They're going to disappear. I'll just be left with the numerator. I have some x squared terms. So now it goes back to what we were talking about earlier. It's not really set up for the square root method, right? We have x's all over the place. We can't really isolate an x squared term. So let's try to rearrange it, put it in standard form, and see if we can factor it or we're going to have to use the quadratic one. So let's see. I'm going to write this in descending order. 5x squared plus 30x plus 90. Sorry, minus 90. And then I'm going to move this stuff over. Minus 4x squared plus 12x. So 5x squared minus 4x squared is x squared. 30x plus 12x is 42x. And then minus 90 equals 0. So let's see if we can factor it. Are there any factors of negative 90 that give us a positive 42? That's a good question. 90, 1 and 90, 2 and 45, 3 and 30, and 18, 6 and 15, 3 and 9 and 10. Are any of those, ordering the signs, going to give us a positive 42? Because in order to get a negative 90, they'd have to be different signs, which means the difference would have to be 42. We get close here. The difference here would be 43. But it needs to be 42. So since it's not factorable, where do we have to go? Quadratic formula. I've run out of space, so I'm going to erase some of our prior steps. So we have x squared plus 42x minus 90 equals 0. What would our a be? B would be 42. And C would be negative 90. Ooh, big numbers here. Alright, so x equals negative b, so negative 42, plus or minus. B squared minus 4 times A times C over 2 times 1. I'm hoping somebody can tell me what 42 squared is because it has figured out. 1764. And then notice here we have 2 minus signs. So it's going to be a positive 360, correct? Over 2. And then 360 plus 1764 is 2124, I believe. And then we would try to come up with perfect square that goes into 21, 24. Let's see. Where goes in there? Does 36 go into 21, 24 evenly? Can someone work out? Can someone divide 21, 24 by 36? 15. Yeah, cool. Save my basic arithmetic. The biggest perfect square that ends up going into 21, 24 is 36. What's the square root of 36? 6. Okay, 2. So the radical will simplify. Can I reduce the fraction? Yeah, 2 goes into both of those. So what's 42 divided by 2? 20. Right, so negative 21. 6 divided by 2? 3. 3. Square root of 3. Yikes. That's a lot. Alright, let's hope the next one's a little bit easier, because that was a little bit intense. Any questions over that one? That's a lot. The next one says 36x squared minus 1 equals 0. Any ideas on how to approach that one?
Square
You could do square root method. So I could add 1 to both sides, and then divide by 36. So x squared equals plus or minus the square root of 136. So x equals, once again, if you have a fraction, you can split it apart. So what's the square root of 1? 1. What's the square root of 36? 6. And there's my 2 answers. Anybody have another idea on a quick way to solve that one as well? There's another way. If you're good with factoring, this is one of those that both of these methods are actually pretty quick. If you can recognize that it's a difference of 2 squares, you can factor it. And then solve those 2 factors. You end up with the same answers, right? Plus or minus 1/6. They both show up. Both take about the same amount of time. So it's one of those that 2 methods kind of take you the same amount of time to work. Any questions on that one? No? Can we do the square root copy? Not isolated. Well, factor? Maybe. What's 8 times 1? 8. Are there any factors that add up to 8 that also add up to a negative 4? So our only two possibilities for 8 would be 1 and 8 and 2 and 4. And there's just no way with the signs that we can get that to work. Doesn't factor. Find out for me. A is 8, B is negative 4, and C is 1. Yeah, so it doesn't factor in. So going back to our quadratic formula over here, x equals negative b, the opposite of b would be 4, plus or minus b squared minus 4 times a times c. And all that's going to be over 2a again, so 2 times 8. Negative 4 squared is going to be positive 16. And then negative 4 times 8 times 1 is a negative 32. And 2 times 8 is 16. So what's 16 minus 32? Negative 16. So I've got 4 plus or minus square root of negative 16 over 16. Can I simplify that radical? Yeah, it would be 4i, because it is the square root of negative 16. So 4 plus or minus 4i over 16. Is there any way I can reduce that fraction? Is there something common to all 4 pieces?
16 is almost.
Yeah, so is there something common to all? Is there something common to 4, 4, and 16? 4. So we could just actually divide all of these by 4. And if you do that, you get 1 plus or minus 1i over 4. And that would be my answer to that one. Let's go ahead and call it there, so the next class that comes in, they should be here pretty shortly. Thank you for showing up. Appreciate it. If you have a chance to fill out the evaluation for feedback, I really appreciate that. And when you're done, just place it face down right here on the desk.